everybody, here's how we're going to analyze your graph now. This graph, if you look at your y-axis, is counting up in degrees. Where is degrees in this problem? I'm not talking about degrees in temperature. If you look back at your robot for a second, we have a wheel. If this wheel starts in this position right here, with this pointing up at 12 o'clock noon, as the wheel rotates, it's rotating through some angle. How many degrees are in a single rotation? By the time this gets back up here, it has traveled 360 degrees. Well, that might be useful for understanding how much this wheel went around, but it's not very easy to understand how far your robot went across the ground if that's all the information we have. So we are going to calculate how far your robot went for each of these transformations. So, in the bottom left corner of your screen, we are going to be able to analyze and manipulate your data. You'll notice we started on this basic setup tab. This was how long our experiment was running. This next tab right here tells us what our graph is of. It's of this rotation data that your robot collected. And there's this purple data table. I'm going to change color for a second so you can see it. If I scroll across here, you'll see here is my x-coordinate, the time, and here's my y-coordinate for every single point that I've plotted. In fact, if I change the color of my graph a little bit and I make those bigger, you can see each point that's been plotted on my graph. That's where that line has come from, right? It's the matching curve for each of those parts. So, what we're going to do, we want to turn this from a graph that's about degrees and eventually get to centimeters per second. Now, you need to pause and figure out here, how can we relate how much your wheel turns to how far it goes? I'm serious. Pause the video right here, turn to your neighbor and tell them, how can we relate the degrees a wheel has turned to how far the wheel went? In other words, ask yourself this question: what would happen if you put bigger wheels on your robot? Would it have driven farther, shorter, or the same with the same motor and the same program? What about if you had put smaller wheels on? Farther, shorter, or the same? Turn and talk to your neighbor. Okay, by now you've figured out we need to find the circumference of your wheel. There's two ways to do this. One is with math, where you can use the equation for circumference, which is 2 times pi times the radius of your wheel, or sometimes it's easier, especially with something big and bulky, pi times the diameter of your wheel. So give one person in your group, whoever likes math the most, that job. They should find the circumference by measuring your wheel that way. Second way you can do it is by measuring around with a string and then lining that string up with a ruler. I want you to pause the video here and take a second and do that both ways. Find the circumference both ways. I mean it. Pause the video. Find the circumference. Okay, make sure you wrote down that circumference because we're going to use it later in the following calculations. We need to turn your graph from degrees to centimeters. We want to get over here because then I can look at a ruler on the ground and say, that's how many centimeters my robot went along the ground. So we're going to do two calculations. One, we're going to take our data and divide it by 360. That's going to tell us how many degrees happened and how many rotations of your wheel that meant. We're doing that because we can take that number for rotations, and now that you know the circumference, you know how big one of those rotations is. If we take this new data, this converted data, times that circumference you just measured, it's going to graph centimeters per second for us. Okay, so here's how we do that. I'm going to go down to the third tab in my lower left corner right here. It even looks like a calculator, and my mouse says Data Set Calculation when I put my mouse over it. If I click this, it opens this big gray box. This is like a graphing calculator screen. Here's some basic and actually more advanced mathematical computations. So in this little box, here's all the buttons I can put in my calculator. A little different than having the buttons and numbers right there, but we're going to be using just division and multiplication for ours. And then here, This is the entire data set that your robot collected. This is every single point listed all together. Instead of having to do math to convert each one into centimeters, we're going to be able to just click this and bam! Did you see that? I can click it again. Oh, it puts it over there every time. It's just putting every single data point in that set into my calculation box. So I'm going to put it one time. You can delete it just like it's text. My calculation is to divide by, and then on my keyboard, 360. My green calculate button has lit up. So when I click this, my graph twitches, and it has plotted a new line for me. Now that line looks ridiculous, right? So I have to scale it just like the other one. When I come over here to my y-axis, I have this new axis right here. When I click that, oh, look, it plotted those points right there. They're hard to see because they're right over my purple ones. I'm going to change them to yellow, and I'll do boxes instead of circles. Okay. The line, ooh, no, boxes. Totally like the boxes. Okay. So, there we have, you can see that it matches in shape. It was off a little bit for a few parts of this, which is okay. It matches for the most part my calculations from the first graph. If I look at what my y-axis says, it says, okay, I started at 0, and my wheels went around 2, 4, 6, 8, 10, about 16 or 17 times. That's how many times your wheels turn. We're going to do another calculation now. I go back to my calculator. I'm going to delete what's on my graphing calculator screen by just clicking the backspace button and highlighting it. Now, see over here for my data sets, I have a new one. This calculated one are all these yellow points. I want to use those. I'm going to click calculated. It puts it over here, my calculated data set. And now I'm going to multiply by my circumference. I made up a number. This is pretty close. You should be somewhere between 17 and 18, or shouldn't be over 19. Okay? Multiply by your circumference. I'm going to calculate now. Same thing, it plotted a graph that doesn't make any sense. It's a ridiculous color compared to the other, so, you know, I never pick blue. I always leave blue out. That's pretty. And I'm going to do big circles for this one. Now I've got this graph. I'm going to auto scale it like the others. It added this final y-axis right here. If I auto scale it, here's how we check and make sure it makes sense. I started at 0, right, at the starting line, and my robot drove forward slowly, faster, 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 and it ended up here at almost 290 centimeters. Well, think about it. How far did your robot go? About 3 meters, 300 centimeters. So now this blue graph shows us how far the robot went. I'm going to turn off my other data sets because they're in my way by clicking these little eyeballs down here. So I'm just going to be looking at my blue one. All right, I'll see you in the next video for how to analyze.